In this video, we talk about NUTX development on a Mac OS machine with Apple Silicon inside, and why we might need an Ubuntu PC to handle the more complicated builds. If we are compiling a simple target for NUTX, ARM, RISC-V, or Extensor, it compiles OK on Mac OS because the tool chains are easily available. We see here that Mac OS compiles NUTX neatly for the AUX64 RISC-V board. The build completes within 1 minute. This is for a Mac Mini on Apple Silicon M2 Pro. What about a complex target for NUTX? Like a TensorFlow target for machine learning. Sadly, this TensorFlow target won't compile correctly on Mac OS. We have trouble compiling simulator targets on Mac OS. It fails with a clang error. Is there a more reliable way to compile all possible NUTX targets while keeping Mac OS as our primary development machine? Yes, there is. Right now, I use this setup to compile all kinds of NUTX targets. Our Mac OS machine runs VS Code with the remote SSH extension. It controls an Ubuntu PC via the remote SSH extension. Mac OS commands our PC to compile NUTX inside a Docker container by downloading the Docker image for NUTX. To install inside VS Code, look for the remote SSH extension. The name of the VS Code extension is kinda misleading. Mac OS connects to our PC over our local network. Technically, we don't have any remote access. After installing the VS Code extension, click the Remote Explorer in the left bar and connect to our Ubuntu PC over SSH. Then, we open a folder on our Ubuntu PC. We run these commands to compile NUTX inside a Docker container inside our Ubuntu PC. We might think, isn't Docker slow? Won't Docker limit our I/O bandwidth? How fast will Docker build TensorFlow for NUTX? Let us start the timer. This is our Ubuntu Xeon workstation with 12 CPU cores inside. It is a refurbished workstation that I got for $400. The machine works like new. Kind of obsolete because it doesn't support Windows 11, though it is a monster of a PC. Xeon Workstation sounds overkill for NUTX development, but we're actually running it as a community-hosted build farm for NUTX continuous integration. All day, all night, non-stop, our Ubuntu workstation is running 6 concurrent build jobs for continuous integration across ARM, RISC-V, Extensor, and everything else in NUTX. Think GitHub Actions, but hosted locally. Which means we have 6 Docker containers running at the same time, plus 1 more Docker container for our TensorFlow build. In total, 7 Docker containers. Which explains why we maxed out all 12 CPU cores, 24 CPU threads. We have 64 megs of RAM. Half of it is used right now. Thus, compiling NUTX is heavily CPU bound, not so much RAM and I/O. Heading back to our NUTX build for TensorFlow machine learning. Is it finished? Yep. TensorFlow builds successfully in 5 minutes on our Ubuntu Xeon workstation. And that is how we run VS Code on macOS, controlling a refurbished Ubuntu Xeon workstation, compiling NUTX inside a Docker container.